Well, hello, folks. So here I am at the end of this time in India. I've literally got just a few hours to myself before I have to head back to Australia. So I thought I'd have a little bit of fun with that and look at a topic that flat earthers sometimes talk about, and but they don't talk about it very much. They just mention it casually. So I want to have a look at it and see if I can't explain some basic concepts here, okay, with this. So if you have a look at the board, it's obvious what it is. It's Abiogenesis, which basically means how did life start? What was the genesis of life? Now I know a lot of the flat earth people, and even people who are not flat earth people, believe that there's a God who created all of this. And then there are my friends over here in India who they have 1,000 gods, and there's numerous other gods around, and really one would have to make up their mind about how do you know it's your God that did this, that made this. Anyway, I don't think it's that important, because whatever God you choose, you could say they were responsible for this. So let's say that your God was able to put in the mechanisms by which this was able to happen. So why not? Okay, so I just want to hark back a little bit back to the Big Bang, so that we can have a look at what happened there. Now, one of the things flat earth people say a lot, and that is that something came from nothing. Well, I don't think anybody actually believes that, and it's not what the claim is. So we're talking about a singularity, so in other words, something tiny, tiny, tiny that contains a lot of energy and contains all of the things that were needed for the universe. So I'm not sure that they said anything about it starting from nothing. Okay, so you flat earth people, you need to stop repeating that. Okay? There's some very good explanations for how energy is, because energy is not nothing. Could actually have created this universe that we know, and everything else in it. And even if you believe in a God, you can even take your God even further back than the singularity. Okay, so I'm not discounting your God. This is not a video about anti-God or atheism or anything. I've got very, very, very fine friends who are also scientists and engineers who, like I said, they have their gods and they believe in them. Okay? So, and they are able to differentiate their science from their religion. Okay? So the science doesn't discount the God, if you like, in their eyes. All right, let's start with this. So, here we go. Abiogenesis. All right, and I'm looking at this from the aspect of biophysics and some biochemistry as well. All right, so this is why it's kind of relevant to my area, and it certainly is interesting to me in any case. All right, okay. So even though I'm not a biologist, I did start off as a chemist, and now I'm a physicist. So the other two disciplines I certainly know quite well, and I certainly do know mathematics as well. All right. So, okay, what happened? Well, if we consider the Big Bang as a huge amount of energy expelled, if you like, at once. Now, people who know the details might consider that I misspeak. I'm deliberately making this accessible to lay people. All right, so if you want to be smart and then get on the comments and say, oh, I said this and it's not quite that, well, go ahead. All right, I'm just trying to make this simple. So yes, it might not comport exactly to what you have read or think. Okay, all right. So let's carry on. Now, the elements were created as a result of this this large expansion, if you like. Okay, and because there's huge amounts of energy, it was possible for things like protons to smash into each other, and electrons as well, and then become heavier and heavier elements. So let's say starting at hydrogen, which is the first element. So enough of the materials that makes up protons managed to get together and create this. There was enough energy for this proton to be created, and as a result of this, and also electrons, and of course light was created because at that stage the energy that was given off at that stage, produced wavelets or photons. Okay, I'll do a video on photons later, because that's something that is particularly interesting, and although it may not be interesting to flat earth people, it's interesting to most people, I think. So I'll do a video on that later on. Anyway, so these elements are created along the way. Heavier elements are created. Iron, for instance, was prevalent as a result of this expansion, and naturally hydrogen. And then, of course, came these gases. And in particular, you see up here, we've got hydrogen gas. By the way, H2, because hydrogen, like all the reactive gases, go around in pairs until they react with other things. Oxygen, O2, N2, nitrogen, and carbon. Okay, so those are the main things. And then, of course, there's the other gas, much heavier gas, chlorine. Okay, and to a lesser extent got involved in this. So we've got these gases that are around that have been created. Now, naturally, these gases are under pressure and temperature pressures are going to join together, are going to create compounds, and compounds such as water, for instance, H2O. Like I said, iron was one of those elements that was created in the early stages, and so was sulfur. So iron and sulfur got together, creating iron sulfide. Okay. Now we have water, we have hydrogen, we have oxygen, we have nitrogen, and hydrogen and nitrogen get together and they create ammonia. Okay, so NH3, for instance, is one of the compounds, just hydrogen and nitrogen together. Okay, now these are additional gases, so these are gas compounds, if you like. So water is a gas compound, H2O, NH3, so ammonia is a gas compound, and of course as a result of ammonia, ammonia ions were created, which are NH4 plus. So you can see that it's quite easily for these atoms to form together, to bond together, to create all of these different types of compounds. Okay. Now, as the Earth is cooling down, I won't discuss. I mean, obviously, the moon is something must have struck the Earth, which caused something to the breakaway, which then created the moon. But we'll just leave that alone. The Earth is cooling down now, so the Earth is now rich in these gases, and also the molten metals and other light elements that are there. And the reason that it forms a ball is because of the interactive forces that makes it necessary to be a ball. Okay, so things are heading towards center of any mass. As the center of mass is created, as things build and build and build on the center of mass, then they must form a sphere. Okay, and the reason they must form a sphere because every single molecule is trying to get to that center of mass. Okay, and as a result of it trying to get to that center of mass, its shortest distance to that center of mass will obviously be at the surface of it a sphere. Okay, now naturally it's not exactly a sphere because I mean we have mountains and things like that, and for all sorts of reasons they come up. Now they're not there. They form as things are cooling. So, for instance, volcanoes. As things cool, bits of land are pushing upwards and creating faults, and all of these things are creating your hills and mountains and that. And then we've got erosion by water, by ice, by wind. All of these types of erosions start making hills and valleys and the like. And then glaciers, all of those things contribute to making the landscape of the earth, if you like. Okay. Now, as the earth is cooling down, water is there. So we've got liquid water, and liquid water then, these gases are able to dissolve in the liquid water. Okay. And so these gases, including CO2, by the way, which I didn't put up there, will dissolve in this water and create what, as you probably know, is called a primordial soup. Okay. All right. So, and really, all that means is this: if these bodies of water, if you like, that contain these specific gases. Okay. All right. So, and including iron and sulfur. All right. So imagine that. If you want to see some evidence of this kind of thing actually happening, for instance, there was recently, unfortunately, in New Zealand, a number of people, I think 6 people who were killed when a volcano erupted while they were visiting it. So this is a bunch of tourists went to visit a volcano, and 6 of them got killed. Okay, because it erupted while they were standing on the edge of the crater. And I've got some pretty good experience with that because I have actually stood on the edge of the crater on the big island of Hawaii while the volcano was active. So that was pretty scary, but very, very exciting. So I'm lucky to be here, I guess. And you do stupid things when you're young. I certainly wouldn't be doing that now, and I probably wouldn't have done what those unfortunate tourists did in New Zealand. But you never know. I'm 66, so I probably would take some risks. Okay, so now these get together in this primordial soup and they create compounds called amino acids. Okay, so in other words, that's not hard to imagine because we're talking about nitrogen, hydrogen, oxygen, all of these things getting together in compounds. So they make molecules, they make cyclical molecules, but importantly they start making chains. So smaller molecules start joining with other molecules and creating chains. If you want an example of a chain, well, plastic is an example of, let's say, polyethylene.